Okay, let me start this recording. All right. So the topic for the day is span, RSPAN, ERSPAN. Simple topic. We use these two features to capture the interesting traffic. Okay. So let's say if I'm troubleshooting some latency issue, or if I'm troubleshooting some slowness, I need to apply these features which will let me know what kind of packets that I'm receiving on that interface, what how many or what is the bandwidth of the traffic that I receive on particular interface. Okay, so I'll tell you what are the two differences between span and RSPAN, and similarly how ERSPAN is one among its family, but it's a different, different. It's little different than these two. Okay, so whole together, all three are different, but we can interrelate them in from the functionality point of view. Okay, the functionality is same. The working behavior is different for all the three in this case. Okay. Okay, so let's move on to this sheet. So this is the NAT which was covered in the previous class, the patting. Okay. And what about the assignment? Have you guys tried it out? Maybe if you want a time in the weekend, so you can try it out during the weekends. Okay, span, RSPAN, ERSPAN. Okay, so let me explain one after one. So let's consider spanning first. Okay, let's consider span first. So you might have heard, or you might have engaged the Cisco tag multiple times whenever you see issues like slowness, right? Or if there is some latency issue in your data center, or if someone reports that application is running very very slow, and you need some expertise who can take a remote on your network and see what kind of traffic is that particular device handling. Let's say this is a switch, so we would like to know what kind of packet is this particular interface is responding to, what is the bandwidth of this packet, right? There's no other tool to get the analyzer. So basically you can see the CPU which will show on high percentage. You can see the interface status which will show you that the TX and RX consumption is very high, right? So you can see the things, you can see from overview, you can see, but you will not be able to sniff the packet. Okay, or I mean to say, you will be not able to analyze the packet. In the case of ASA firewall, if you remember from our previous class, we have some features called as capture. Okay, if I make use of this capture command over on an interface, I can see whatever packets are being received, or whatever packet is being transmitted. But when we deal with these iOS boxes, okay, the low end boxes, so they are not capable of having this inbuilt features. So how do you analyze the packet? So there should be some way to analyze the packet. Let's say these are the network devices, right? They are network devices, so there is no way you can install a Wireshark between here, because they are network devices. If it was a host, or if it was a computer, might be you could have installed Wireshark or if they are running on a Linux box, you could make use of the TCP dump command, and you could have taken the capture for last 1 minute or 5 minutes to see what kind of packets are being entering or being transmitted out of that interface, and you could have given the analysis to those engineers, the network engineers from that company. But on these small end devices like layer 2 switches, there is nothing called as TCP dump. There is nothing called inbuilt capture, so you do not have any way to see what is happening on that interface, and users are reporting that the packets are getting dropped, or packets are facing or there is a lot of slowness. If someone is initiating a ping, they see there are a lot of packets getting dropped. If they see let's say they are trying to browse a application, and it's very slow, right? So you will see this kind of tickets getting created on your day-to-day operations, right? So span is one such technology with which you can capture the packet, and you can take it in a Wireshark format, or if you have any other sniffing tool, you can see like for a span of 1 minute what all packets were captured, what are traffics are entering and transmitting on this interface. There could be reason that the problem is little complicated. Let's say this was the network design, okay, and you have some server here, and over here you have some trunk. Now you know trunk is gonna carry lot of VLANs. It's gonna carry lot of VLANs, right? How are you gonna find out who is the culprit now? How are you gonna say that the VLAN 30 is something which is taking a lot of bandwidth here? You don't have any proof to prove that, right? And move this VLAN 30 somewhere else. So the span comes handy in this kind of troubleshooting scenario. When you enable span, you can see the whole traffic which is in and out, entering and leaving out of this interface, okay? And with the help of any third party tools like one of them is Wireshark, you have a lot of other sniffing tool. If you have some Linux box, you can make use of some analyzer, and you can see what is the packet to and fro for VLAN 30 when compared with other, and accordingly you can suggest the management that the 30 is getting utilized and we would like to move it to a different switch. So this is with respective to collect the traffic and then analyze it. There is no default command to get this thing going on a iOS box, okay? So what is span? Span is nothing but it's a switch port analyzer. It's called as switch port analyzer. Now, when I say that there are three different topics for the day: span, RSPAN, ERSPAN, okay? All the three, the functionality is the same. They're gonna do the port analyzer, but the way of working is different. So let's say I have a switch, I have a server, and let's say my span analyzer is on the same switch. I have another host or a computer which is running Wireshark. Okay. Now this kind of design, when the traffic is being monitored on this interface, and whatever is captured is getting being sent to the upstream Wireshark analyzer. Okay. Now this kind of approach is called as span. It's on the same device. Your analyzer and your the source, I can say source this and destination this on the same switch is called as span. Now let's say for some reason this analyzer was not on the same switch. Instead it was on a different switch. Now let's say this is a switch 1, this is a switch 2, intermediate you have a trunk configuration. Okay, and you are making use of your Wireshark over here. Now in this case, you're monitoring this interface, you're sending that packet over on trunk, it will go to switch 2 and switch 2 will send back to not send back, it will send upstream to the Wireshark. Now in this kind of design, when the destination is not on the same switch, it's remote, we call it as remote span. Okay, remote switch port analyzer, and this was a simple analyzer where source and destination were on the same switch. This is when source and destination were in two different switch. Now what is ERSPAN? When I said span and ERSPAN, they were capable of L2 traffic. I was talking about from the VLAN point of view, right? There was no routing involved. Whereas ERSPAN is for routed port analyzer. Okay, it's a routed port analyzer. And how do we get this? We need to have a GRE tunnel built so that we can configure. And the second thing about ERSPAN is this is not seen in iOS. iOS is not capable of doing ERSPAN. ERSPAN is a latest technology, and to do this lab, you need to have some iOS XE boxes. Only then you can do that. And if you see our network topology for this batch don't have any XE box. Okay, so you can try with this CSR 1000V. Okay, this router which is available for free, which we can install on GNS. It runs on iOS XE. So for this ERSPAN, I may not be able to do the lab today. Might be if I introduce CSR 1000V on my GNS, then I can show this in the next class. Okay, but I'll tell you the theory. What is this? The approach is same. All the three are gonna do the port analyzer. It's how the destinations are connected. If the destination is on the same switch, wherever you have your source, okay, let's say source is this, you wanna analyze this port, and the destination is here, the analyzer, then such designs are called as the normal span. Okay, it's called as span. When let's say this was not on the same switch, we had another layer 2 switch, and we have the Wireshark analyzer here. So such kind of designs are called as remote span. And ERSPAN is little latest one. It's a latest one. It don't run on iOS. Okay, we need iOS XE. And one best example that you can check is this router. Okay, so this comes with XE family. Okay, so let me now show you one after one. Basically, what is span and RSPAN we normally configure with, or what are the limitations of these two protocol or the technology, and later on we will talk about ERSPAN. Okay, so I'll take span and RSPAN together, and ERSPAN later on. Okay, so what are the limitation of this, or how does it look like? So if I show you this PDF, so as I said, span, the normal one, the first one, let's say this is your server. Okay, and the user of the server are reporting slowness, and this is your first point of your switch that's connected, which is your switch. Okay, now whoever from Cisco tag is joining your call to troubleshoot, what he's going to do is he's gonna put some monitor session, okay, over here. This will act as the source, and now you need some third party analyzer. So you can make use of Wireshark, or you can keep a computer or a system, and that system has a Wireshark. Okay, and now you give this port as the destination. So the configuration is very simple, just a 2 commands of line. So whatever you receive, you will start forwarding to this computer, and you can see whatever is this interface collecting, and then you are gonna say that the traffic for VLAN 40 is 80%, the traffic for VLAN 10 is 5%. So this is the culprit who is consuming lot of traffic, and there is lot of reset packet flapping is happening on this VLAN. So it's gonna help you to see what kind of traffic is getting discarded, which kind of VLAN is consuming a lot of high bandwidth. Okay, so that will help you to understand. So basically every traffic from, let's say if this was a trunk traffic, okay, which was carrying might be 100 of VLANs within them. So basically you cannot make sure, right? You can of course see what is the overall status. It will show you something called as RX and TX, which could be choked up, which could be showing as like 200 by 200. That means there is a lot of utilization going on. If you see from the percentage CPU, the CPU will be high. So you can see from the overall counters or the statistic of the device that there is something going on. But until you enable the span session, you will not come to know exactly what is consuming. So the main concern here is to find out the traffic which is consuming the highest bandwidth. Okay, so the first one, that is span, it's when your source and destination is on the same switch. This is one of the assignment which I'll give you. Okay, maybe you can try in the weekend. I'll demonstrate one in the class, and the second one I'll give it for you guys to do it on your own. Okay, it's simple. If you know, you can open a packet tracer, or if you have GNS or EVNG, you can just try to recreate them, and you can just follow whatever the lab I will show it today. Okay, what you need to do is, let's say these are two computers. This is the switch where you see the latency or the drop happening. So basically you need some computer. Okay, and for a computer you just can connect a router or something. You don't really need a 5 to 10 GB of a Windows machine, all those things, because this is just a lab, right? So you can just install a router and just run the Wireshark over on this interface. It's very simple on GNS and EVNG. You can right click on these interface and you can open Wireshark. So if there is any span happening here, it's gonna forward and you can see, analyze it on the Wireshark. So that's the whole approach in the lab. Okay, fine. So as I said, the difference between span and RSPAN. Span is when both are on same. RSPAN is something when the destination is on another switch. Okay, and they are on a VLAN trunking. So the two switches are connected on trunking, something like this. So this is your switch 1 and this is your switch 2. Why do we use this kind of approaches? Let's say this switch was 8 port. Okay, and there is no free port where you can connect your sniffing analyzer tool. Now in that case, you cannot make, or you cannot use any port for analyzer. Or let's say this was already consuming lot of traffic, so you cannot get another computer on the same thing and start putting a load on the CPU or the memory usage of this particular. Okay, so let's say the design was something like this. You have your normal VLANs configuration here, and inter switches you have your trunk configuration. Okay, so you need to make sure whatever VLAN that you're gonna put on analyzer. Okay, let's say you're trying to target 40, you can also target 40. So as I said, let's say this is also in trunk. Okay, and in trunk, you know that there are couple of VLANs that we can allow, 10, 20, 30, 40, 50, so on. Let's say you put your normal span or RSPAN and you were able to see that there is a lot of traffic happening, and you also found out that 40 is the culprit. Now what you can do is you can remove capturing everything, because in production that's not a good idea to put the analyzer on all the interfaces, all the VLAN. The reason is, let's say this was capable of 100 Mbps. Okay, the moment you start the analyzer on all the traffic on all these VLANs, now who is gonna get suffered? It's this interface that's gonna suffer, right? Because this is already getting dropped. That's why you're initiating this kind of approach. This is already getting dropped. Now the issue was this. So whenever you're capturing in a lot of space, you're forwarding it over on this interface. Now this trunk will suffer. And let's say there were other VLANs right? Other VLANs than these. Let's say there were some other VLANs like 200, might be 300, which was also part of this. Now they will also suffer. So it's not a best practice in the production to keep the analyzer open for all the VLANs. So we would apply something called as filter. Okay, so I'll say that only interesting traffic on this is only for VLAN 40. Rest you just ignore it, I don't mind. So when the traffic here is being detected for VLAN 40, now that will be only sent on this trunk. The switch will also have some RSPAN configuration enabled. We normally enable monitor session. Okay, so this monitor session has to be enabled on both of them, and this is your Wireshark, and Wireshark will able to help you to see the capture only for VLAN 40. You can see how many packets are being RX or TX, that is receiving and transmitting. Now the good point about this span and RSPAN is, now let's say we are trying to narrow down the issue. We first put the span on multiple VLANs, then we reduced by with the help of filter. We still want some better output, right? Now what I can do is, let's say on this interface there are two types of traffic in from the direction point of view. One is receiving something going to this box from out of this switch will be called as TX, right? So this switch, if he's sending something to the box, that would be transmitting traffic. Now let's say that computer was sending some traffic to the switch. Now that would have been the receiving traffic on this interface. So think from this interface point of view. If you're receiving something on this interface, that is called as receiving. If you're transmitting something, or I can say sending out something out of this, that would be TX, right? Now let's say the advantage of the span or RSPAN is it's also allowing you to filter now whether you're focusing on the TX traffic or only RX traffic. Let's say you're only interested in the RX traffic. You don't mind sending out something on that. You're just interested on knowing what or how many types or how many what is the size of this VLAN 40 traffic. So you can just filter it once again with RX traffic. So with this filtering, you can reduce the unwanted burden on the switch, because that switch was already facing a lot of overhead because of these span monitoring, the lot of traffic hitting, the initial troubleshooting why the user had initiated the call. So you don't want to put a lot of burden still by having all the broad kind of command. So you can just filter it out. You can filter for a single VLAN. You can filter it in terms of receiving or transmitting. Now that's a good thing about the span. You can bring or you can get few more commands to improvise your span monitoring. You don't need a lot of things. Let's say for 1 minute you captured thousands of traffic, but the only thing you were interested was VLAN 40. Now you have to go through all the 1000 line, then you have to do your own analysis, right? So it's better put lot of filters here. Filter, like if you want to check for only VLAN 40 and you need only RX. Now instead of 1000 you might have got or might have received 100 only, and now from 100 it would be easier for you to see what is the TCP reset flag, or what was the time it took for the RTT for sending and receiving back the response. So a lot of things will become easier when you take the very precise captures. Okay, so that was regards to RSPAN. Once again, for RSPAN I have this assignment for you guys. Okay, I'll do one in the class today, and the second one I'll give it to you guys. So you need two switches. As you know, RSPAN is something when the source is on a different switch and a destination is on a different switch. Okay, so this is a RSPAN example. Now let me talk about the limitations of this, or what is these two technology capable of, and what are these to technology which they cannot handle, or they cannot be able to handle them. So I can write it as like restrictions. Okay, so it's not only about restriction, or I would say that limitations. Okay, restriction, limitations, or benefits. Okay, so the first benefit is, that by default the switch, okay, so that by default a switch, if you enable any thing, like a span or RSPAN, okay, it's gonna capture all the traffic and then it's gonna accordingly work. So in case of span, it's on the same switch. If it's RSPAN, then it's on a different switch, right? So what do you mean by default is, even the by default packets, like your STP packets, CDP packets, DTP packets, VTP packets. There are a lot of packets, BAGP packet, sorry, PAGP packet, the ether channel packet, even they get included. Okay, now those are unwanted packets. You are not concerned about this, right? So the benefit is, with the help of span and RSPAN, we can make sure that they are not copied. Otherwise, that would have been a drawback of this particular technology. The good thing is, by default, they don't get copied. Okay, something by default, this span and RSPAN by default will not copy those default packets. Okay, but yes, if you are interested to capture even those, then yes, you can enable them. So you can enable so that these default packets also get captured and being sent to the analyzer. Okay, so you can take it as a benefit or you can take it as a limitation, up to you. Okay, second point. So second point is, when I say the source, okay, now this can be in a different mode. I can say that it's a layer 2 switch port. It can be a layer 2 switch port. That's nothing but your access port, simple words. It can be a trunk. That's nothing but your .1 queue. Okay, it can be a routed mode as well. Okay, it can be a routed mode, it can be access port, it can be trunk, also it can be a ether channel. Okay, once again, it's up to you. You take it as benefit or limitation or restriction, but they are covering lot many modes. So I would say that there's a benefit. Otherwise, the limitation would be that it's not capable of handling trunk, or if it's not capable of handling the routed mode, right? So basically it can handle lot of modes. So that's a benefit on these low end devices, right? Because you don't have any other way to enable the span. What about the next thing? So let's say over on this interface, okay, the source interface, you can basically use multiple interfaces. Okay, you can use multiple interfaces. You can also use multiple VLANs. Okay, but what is the limitation here? So limitation is, you cannot mix them. Okay, you cannot mix the interface and the VLANs. That means, let's say on this switch port, I had something like the default VLAN 1. Okay, now that particular VLAN you might also have somewhere else. Might be this is also VLAN 1, might be this is also VLAN 1, right? So you can enable this monitor session focusing on VLAN 1 from multiple interfaces. So you can have multiple interfaces. You can also, let's say if it was a trunk, then you could have multiple VLANs, but you cannot mix multiple interfaces and VLANs. It either have to be one. If it is multiple interfaces, go with multiple interfaces. If it's multiple VLANs, then go with multiple VLANs. You cannot mix interfaces plus VLANs. There should be difference. Okay. Point number 4, as I told you, if you don't apply filter here, okay, if you don't apply filter here, you are gonna capture all VLANs and you're gonna try to forward it to your destination, right? And if the destination or let's say the trunk between them was only 100 Mbps, so basically it's very easy for the span or RSPAN to overload the trunking. Now that's the limitation factor. Okay, so you have to be little careful when you deal this in the production environment. So don't try to put all VLANs. Go with the filtering here. As much as filtering you can enable. There's one more limitation, or I can say restriction or a drawback. So if you see the configuration point of view for SPAN or RSPAN on the destination port, let's say this is the destination port for SPAN. What is the destination port? Destination port for RSPAN would be this. Okay, this will be destination. Now, as soon as you configure SPAN and RSPAN, the default configuration, I mean the configuration of this destination port, let's say this was 0/1 and this was 0/1 of different switch. They are gonna be getting default. That means if they had some configuration, if they were on a trunk or an access port, the configuration is gonna get wiped. Okay, the default configuration is getting originated now, or I can say whatever configuration you had, they are gonna get default. Okay, the default configuration that's required for SPAN and RSPAN is going to get created, and they will only carry the traffic which is generated or which is required by SPAN or RSPAN. There will be no other data traffic. Okay, it will be only traffic is this destination port. I can say that this destination will be only connected to the analyzer or the computer which has that analyzer. It's not going to do any other job. That's why my first point I said the limitation of SPAN was, let's say if there is no free port, right, and you cannot make use of the same port for different purpose as well as for capturing the SPAN traffic. So we only end up with is that to find a free port on a second switch and then connect our computer and have the analyzer and get it going, right? So as soon as you enable SPAN, that you have to enable the SPAN configuration. So the configuration command would be something like this. You have to define which interface is your source. Let's consider this is this, and you have to also define which is your destination configuration, where exactly is your analyzer connected, the Wireshark connected. So the moment you say it's on this, the configuration will be wiped out. It's going to be default, and it's only going to carry the SPAN traffic. That interface, you cannot use it for any other purpose. Okay, so let me clear this. I have covered almost all. Okay, and for your reading purpose, I have documented here, so you can, okay, one second. So you can go through this whenever you're preparing for your exams. Okay, fine. So we did with a lot of theoretical topics. Let's quickly see the lab now. So for our lab, what I have done is I've just connected two computers. Okay, two computers which shows as Wireshark, but they are just the icons. Okay, you know how do we change the icons on GNS. So what I did is I connected the Alpine Linux instances. Okay, because they take very less resource from my GNS server, and I just changed the icons. I went to Google and I got one icon. It was quite simple to do that. Okay, so you know how to get the icons. Okay, it should be like 96 into 96 pixels. That fits good. Or you can go with maximum 100 into 100. They are easy to uh, put in. Don't go with very large image. So this was the icon which I downloaded today. So where is it? Where is it? So I'll put this on the group. Might be you can download it, or if you want your own favorite icon, you can go and have it downloaded. Okay, fine. I think it's taking some time to load. They're not so time consuming. Let me open it on a different tools. Okay, let me open it on the default paint. Okay, so here it go. It's a very small icon, 96 into 96 in dimension. So where do I get the Alpine Linux? Once again, go to the GNS marketplace. You might have it already. I've used it to show you this. Okay, so the same two instances I just dragged and I just connected over here, so I can show you the span and RSPAN over here. Okay, first I'll show you span. So let's say this is my server or whatever. Okay, but it's acting as my source. This is the sniffing analyzer, which is my destination. Okay, so when the source and destination are on the same switch, what do we call that? We call it as span, switch port analyzer. Okay, and in the second case, that's while demonstrating RSPAN, remote span, we can keep this as source. Okay, we don't need this because the RSPAN is when you have your destination on the second switch. Okay, so I can keep this as access or trunk, doesn't matter, depends on what you have. If it's single endpoint, you can keep access. If you have a server or some trunk kind of a device, you can make use of trunk. Over here, as usually, most of the time, at least 99%, interswitch will be always on trunk, right? So they will be on trunk. And yes, I can allow all the VLANs. Okay, so only thing is I have to put the filtering on the VLAN or the RxTX over here. Okay, and this would be my destination. So I will go come back to this switch. I'll add some more monitoring session. I'll say that I'm receiving some packets on here and I'm sending destination to this, so I should be able to run the captures. So how do the capture work is, I just go and take the Wireshark capture on this. Okay, so on my lab, it's easy on GNS or even in the EVNG. You just need to right click and get the Wireshark. If it was a production, you don't have Wireshark by just right clicking and getting is not something achievable. You have to have some Linux box or a Windows box, and you have to have those third party tools like Wireshark, or in case of Linux it will be TCP dump, and then those real boxes will give you the sniffing packet or the analyzer. But in the lab, if I go and connect a computer, it's gonna take like 8 GB for the computer to run. There's so much of space required, which I totally cannot afford doing all this thing for showing few things, right? So the best option would be connect a single interface so that you get this kind of cable, right click and get the capture, or get the Wireshark capture. That's the simplest option while having the lab. Okay, so fine. So let's open up the first few boxes. So let me show you the configuration here. As usual, they are on this interface 172.16.40.10 and some gateway. Okay, on my switch, it's layer 2 switch. So I'll just reload this so that I can show you the configuration from scratch. So meanwhile, I'll power on the second box because these switches take some time. Okay. Yeah, I was trying to do this lab over here, but the thing is, unfortunately, these switches, they are IOL type of boxes. Okay. IOU or IOL. So these boxes don't have the features of SPAN and RSPAN. Forget about ERSPAN, which is totally new, which even these boxes cannot handle. So the SPAN and RSPAN will not run on IOU and IOL. They are very old devices. You see the interfaces, they are running still on Ethernet technology. So I had to then move on to this section so that I can show you these SPAN and RSPAN. They are at least a giga interfaces, and the command works good over here. So that's why if you're trying to do it as per your requirement, so make sure that the devices are capable of handling this technology. All right, so the device is up. Okay, let's make sure I do not have any configuration. Okay, so this is the command to verify the monitor session. It says that there is no span configuration. Okay, fine. So let's configure the first type, that is spanning. Not spanning, it's called a span. Okay, so the first type of this technology, as you know, the source and destination will lie on a single box. So I'm gonna configure monitor session 1. Who is my source? Okay, as I said, you can have interface or you can have VLAN, but you cannot mismatch or you cannot mix both of them. You can have multiple interfaces or you can have multiple VLANs, but you cannot have both together. So let's say I go with first interface. Okay, so I say that I go with interface example. Which interface should I take it as source? Should I take it as a single interface? And also I said that span is gonna work good on ether channels, that's port channel, right? So both are good. So let's say I go with giga ethernet, single interface. Okay, so whatever we learned in theory is now we can see it here practically. So who is my source? My source is one with 0/2, this one. Let's say I have some server and users are reporting that this server is not capable of downloading the files, or there is a lot of application latency issue. The users somewhere from this direction cannot access them. So you're trying to just see what are the different traffics that's impacting the real required traffic. So you're just enabling the monitor session. Now once you're done with the source, you have to define where is your analyzer, because these Cisco boxes don't have inbuilt Wireshark, or they don't have any inbuilt command like ether analyzer in Nexus boxes. Like if you know, Nexus boxes have a inbuilt command called as ether analyzer, ETH analyzer. Okay. Also, the Arista boxes have something called as ETH analyzer, which are inbuilt commands to capture this kind of things. Okay. You don't need a external span monitor or a RSPAN. By default, within your box itself, you can enable them, and the session can be captured in the PCAP format, which is your Wireshark format, right? Similar way, if you're good with load balancer or a Linux box, you might have seen the command TCP dump, which does the same thing. It doesn't need a third party to capture something. You run the command, you capture everything in a monitor or in a session, and you just download the file from the directory or a flash and send to the tag person so that he can see and tell you what is the best practice. In ASA firewall, we make use of the capture command. Now, in this kind of box, we don't have anything. We are dependent on a third party span. So I set source. A similar way, I have to say a destination for these. Okay. So I go back to monitor session 1. Okay. Now it's a destination. Now on destination, who is my span? I told you, now remote is something when it's on a different switch. Okay. Now this is on a similar switch, and interface is GI1/0. Okay. So that's all, 2 commands. And if you go with show monitor session 1, so you can see now the session is up. Okay. You can go with detailed. You can see exactly what are you trying to capture. Okay. So it's a local session. It's not a remote session. You can give a description saying that your tag number, because so that might be there are multiple session going on, might be 4-5 session going on, and you do not know which session was created for which tag number, right? So you can give some description that server A to server B, some SR number with tag number 1, 2, 3, 4, so that you know that this particular thing is running for this particular capture. On source port, what are you trying to capture? You're capturing both the things, which I said you can also filter it so that you don't capture a lot of things and don't bring a lot of overhead on the boxes. You can capture both the things. So at the moment, you're capturing both. Okay. Similar way, what is the VLAN that you're configuring? You are not focusing on the VLAN. I told you, you can either target interface or you can target VLAN. As of now, you're targeting RX and TX and every packet from on that interface. You're not targeting any VLANs. But yes, you can turn this off and you can just target on VLAN 100. Might be you are interested to know VLAN 100, the RX and TX. And once again, you can put the filter there that VLAN 100 only for RX traffic. So that's possible. Okay. So it's not a RX VLAN, none. This is the destination port. Okay. Encapsulation is native. There's nothing that you put the encapsulation. Right now, there is no filtering happening and there is no destination RSPAN VLAN. So just to give a try, I will initiate some traffic. I'll just initiate some ping packet. Okay. And I'll also keep some captures here so that we see the traffic over there. Let's keep the traffic here and let me ping this one. Okay. Because when I ping this traffic, okay, even though this will hit on this and the switch will send it here, but since I'm capturing the whole span here, the one copy of traffic should be sent to my analyzer on my Wireshark. Okay. So let's make sure that we get some traffic. So I'll open up the PC9. So let's say I have okay. So I can see the capture is coming on this particular box. Okay. So that means this session is working and I can see there are packets being getting initiated, and someone who is from the TAC engineer, might be they can troubleshoot, they can see what is the flag coming in, what is the delay happening, how many times the packet got reset. So that's up to the TAC engineers. Okay, the thing that we did in the lab is to enable the span. Now let me show you how do you get those filtering enabled. Okay, so let me go back to configuration T, and let's say I wanted to focus on RX or TX. Okay, so when I'm over here, if I do a question mark, so let's say I don't want to focus everything, I just want to focus on the receiving traffic on this interface. So I can say I will put RX traffic. Okay, so this is how we will be filtering these traffic. Now let's say I don't want interface basis of capturing, but I need it to be VLAN specific. Okay, now you will see that if you remember in the theoretical topic, I said that you cannot have interface mixed with VLAN. Okay, on that interface you can have either multiple interfaces or you can have multiple VLAN. So let me do it, and let me show you that whatever we discussed is really not allowing us to do. Okay, so let's say I already had enabled the span on interface. Now let's enable span on VLAN basis on the same interface, and let's see if that let me to do. Okay, I'm going to keep the same session 1. Now source will be not my interface. I'll not my interface. I'll keep it as VLAN. Okay. You have the range command, so you can go with the a range, or you can go with one single VLAN. So let's say I'm going with VLAN 40. Now you see that it's going to give you an error. Cannot add VLAN as source for span session 1, because span session 1 was enabled for multiple interfaces or interface, right? So in such scenario, I must use another session number. So let's say I make use of session number 2. Now that will work for me. Okay, so I said monitor session 2 source VLAN 40. And what about the destination? So destination is something which could be this, or this session number has to be changed, because this session number is associated with the interface capture. So I'll go and make one simple change so that whatever I capture on session number 2 is being forwarded. Okay, so you can see once again it will not let you to configure, because the destination is already been mapped to one monitor session. As I told you, the destination can only have one session. So you have to first delete this and then add the new one. So let's say I'll delete this. Okay, so it's not session 2, it's session 1. I deleted that, and now I'll add this tagged to my new session, which is session 2, something like this. And you can see the span started working. If you just remove that command, there is no span happening. You're still able to ping, because it's a layer 2 traffic. Whatever this computer is doing is it's gonna send those frame to the switch is doing the MAC address lookup. It is directly forwarding to it. The first traffic, the first packet only does the broadcast storm, which hits or floods on all the interface. Once the MAC address has been built, then the next time it's not a broadcast, it's a unique cast. Okay, so now it's a unique cast. But since I have the span configured, I'm giving my destination to be this. That's the reason one of the copy of this traffic that I can see on my analyzer. Okay, so you can see yourself when I disabled it, there is nothing captured on the analyzer. But if I bring it up for my VLAN 40 source, so I should be able to see the captures happening. Okay, so this was the simple thing in the case of the span, the basic span. Now what I do is I'll just reload this once again, because in the case of RSPAN, I need to do few other things, a few other configurations. Okay, so I'll also close this, because now in the case of RSPAN, I don't need this particular snipping tool. Instead, my snipping tool is over here, so I'll bring that up. Okay, so I'll shut down the first one, which helped me for span traffic. Now for our span traffic, this is the one which I'll bring it up. Okay, so let's wait for the switch to come up. I'll meanwhile take the captures here. I'll at least run this. Okay, let's keep it here. There's no traffic right now other than the basic default one. Okay, so the configuration for RSPAN is similar, but there are couple of things, additional commands. In the case of RSPAN, 2 or 3 commands you have to on a top of your normal span, you have to add it here. So as you see on the Wireshark, by default, the switches keep sending a lot of frames. Okay, a lot of packet with for STP, DTP, CDP. Okay, let's wait for this to come up. Okay, so the first switch has come up, switch number 1, or as per my design, it's Moscow switch 1. Okay, so who will be the which interface will act as source? This is going to act as source, and this is going to act as destination. Okay, so on my source end, that's interface GI0/2, I have to specify my VLAN that will be used for remote span. Okay, so that's the additional command here. So let's say VLAN 40 on this interface is acting as remote span. Okay, so there's a command remote span. So that's from the source side. Similar way, okay, so what I'll do is I'll not configure this on the interface. Okay, I'll let me not make it as interface, because I'll show the interface in a different way. Okay, basically what I did is right, but let me try to show you what exactly I'm going to do. Okay, so I'll not apply anything on interface. Okay, I'm not going to apply anything on interface. Whatever I'm going to configure is from the VLAN point of view. So let's say if I go to VLAN 40 of this switch, if I do a question mark, there are a lot of things I can do. All right, so most of the time what we do is when we go on a VLAN 40, we just give name, and we just say it's a VLAN 40, and we come out of it. Right, we never do anything apart from this particular command. But today I'm gonna show you this command that's called as remote span. Okay, so what happens is, as soon as I say that I bring this feature enable, so basically I'm considering VLAN 40 for my remote span capture or traffic analyzer. Okay, so that's on switch number 1. Similar way, on switch number 2, I'll do the same thing. I'll say that VLAN 40 is the VLAN which I need for my remote span analyzer. Okay, so the second switch is here. I go to VLAN 40. As you know, most of the time we only do we usually use the name command, but this time, the very first time, we will make use of remote span, and we'll just bring up the features. Okay, so you just did two things as of now. One is on switch 1, you said VLAN 40 is your remote span, and the second step was on switch number 2, you said VLAN 40 is remote span. Okay, you just basically enabled the features. Now go back to switch number 1, and you have to make sure that this interface is on trunk, which is already in trunk. Okay, but I'll show you what is the trunk that we are using here. We'll make sure that VLAN 40 is allowed on that trunk. Okay, so yes, we have VLAN 40, or if you don't add this command, by default every VLAN will be acting as a allowed, right? So this command says that VLAN 1 and VLAN 40 is being allowed on inter trunking. But if you don't add this command by default and you just keep the rest of them like trunking, encapsulation, and this one, so basically it's equivalent like you have all the VLANs 1 to 4096 or 1 to 1001, everything allowed on that interface, right? So this is the command from inter switch point of view. I'll make sure my second switch also has that, because if that VLAN is not allowed, then basically, okay, so what do you see? Putting GI0/2 in inactive state because access VLAN is remote span. So this is configured on VLAN 40. So it basically said that VLAN 40 is remote span. Okay, so basically it is trying to put the other interface on inactive so that it don't capture from all the VLAN 40. So let me show you. Show IP int brief 0/2. Okay, show interface GI0/2. So you can say it says inactive. The reason is, otherwise what happens, since you have VLAN 40 globally acting as RSPAN, there might be other interfaces on VLAN 42, but you are not interested capturing on them. You are only interested capturing on this source to this destination. So that's the internal part of RSPAN. It will make sure that other unwanted traffics are not being captured. So from the trunking point on the second box, let's see that. So you have a basic trunk and you have an allowed 40, which is important. If you don't allow, then there is no RSPAN traffic gonna carry between the two switches. Okay, now let's come with the source and destination configuration. I'll say monitor session 1. Who is my source? Let's go with interface. Okay, so I say that interface 0/2 is my source, and you also have to define who is destination. Even though it's a remote span, now destination will act as your facing to switch to. Okay, so I say destination. What is it? It's a remote, right? So this time you're making use of remote. And on which VLAN are you going to send that RSPAN? It's VLAN 40, right? Two commands on the first switch. Now go back to switch number 2, and now you are pointing your source and you're pointing your destination. Okay, now what you do is you say monitor session 1, the same session number. Now how you define your sources, you have 3 options, right? You cannot make use of interface and VLAN because that's a span features, the first one. Now we are going with remote option. So I say remote, and which VLAN is this? It's a VLAN 40, right? Now I'll define my destination. So I'll say destination. Now I can make use of interface. If let's say this switch was one more hop away, now in that case I would have given remote, but now it's on my physical interface, so I'll make use of interface. I'll give the number 1/0. Okay, whole configuration is configured. So where is my monitoring? So you see there is nothing enabled now because I have not initiated. Okay, so once I initiate, then I must see some traffic hitting here. Okay, So let's see if we have some traffic reaching till here. So let me end this. Let me see show monitor session 1. Okay, it's enabled. What about detailed? Okay, so from the detailed you see I'm not using any filtering on port, neither on VLANs. It's a source VLAN which I said, and I just said it's a destination. Okay, this comes when I make use of any filtering. Similar way on my source side, that is switch 1 side, if I say show monitor session 1. Okay, it's a source side of remote span. You can see what does it say. It's a remote source session, and over here it will say remote destination session. Okay, now let's initiate some traffic. 40.2. Okay, so did I do any configuration? So it's not running. So let's quickly check that. Show run interface 0/2. Okay, so there's VLAN 40. What about 0? There is a trunk. What about, okay, it's not running because it already made that interface as inactive, right? So my ping will not work. So might be I should take a different VLAN to demonstrate this, because that's how remote span works. Remote span, what it did is it put the interface on inactive. See, it said that putting GI 0/2 in inactive state because access VLAN is remote VLAN. So might be this will not let me to capture the traffic here. Let's see if I can ping something else. .10.20. Since they are not in a gateway, they will not help me. Let's once bounce the port. Let's see if it comes up. No shut. To show interface GI 0/2. No, it's inactive. So the catch is I should take a different span VLAN. So let's do one thing. Instead of VLAN 40 acting as a span, let's take a different span VLAN. So let's say VLAN 1 acting as a remote span. Okay, so that's another catch. For VLAN 1, you cannot configure remote span. It should be anything apart from 1, like from 0 to 4094. So I'll just see what are VLANs I have here. So I cannot make use of 1. 40 is my active VLAN. So let's create a simple VLAN. Let's create VLAN 40. Okay, and let's make it as remote span. Let's see what other VLANs act as this remote span. Okay, so I'll do one thing. I'll go to VLAN 40. I'll say remote, no remote span. Okay, and on my trunk I have to allow this. That's why I said if you don't want to do that, you can just you can just remove the word so that all VLANs get added up. And when you're trying to add something, make sure you make use of this keyword. Otherwise, the previous VLANs will get overwritten. Okay, with the latest one. So this is how you add a new trunk VLAN to a trunk. So we have 140 and 100. Okay, same thing over here. VLAN 40, no remote span, and you can see there are some captures coming now because you removed 40 from the remote span, right? So let's bring 100, which is acting as remote span. Yes, we'll go back to interface and we will add trunking. I say switch port trunking allow VLAN add and 100. Okay. What about ping now? Do we see something from 40.20? So let's wait that interface comes up. Or might be it need a manual bounce. Okay, it's connected now. The moment we change the remote VLAN, it's up. Okay. Okay, why? Okay, they started working, and we can see the packets hitting on this. Okay. So which wasn't working. Now you can see there's a packet hitting up here. Okay. So that's the catch. You cannot make use of the remote span VLAN, which uh, is the traffic that you're trying to capture. Make sure you make use of a different VLANs. So if I see the monitor session, okay, so this is still pointing there. Okay, so let's change that. This command has to be taken out, and I'll make it as 100. Okay, and the same thing over here from the source side. So you have this command, which I'll take it out, make it as 100, and there you go. Now you can see the captures coming in, right? So that's what regards to span and RSPAN. So you know what happens when in the case of span and RSPAN. Make sure in the case of RSPAN you consider a dedicated VLAN for RSPAN. Don't make use of the VLAN which you are trying to analyze. Okay, because the moment you use the same VLAN on your destination side, the port will be put up into inactive state, because that's a safety feature from our span, right? Otherwise it's gonna capture the traffic from all over the switches, which you don't need it. So make sure you have a dedicated VLAN. You can keep a spare VLAN for RSPAN, and with the help of interface as source and destination as interface, you can start capturing. Okay, so that was something which was for RSPAN and normal span. For you guys to practice, I'm giving you this diagram. So as I told you, you can make use of packet tracer, no harm. You can make use of GNS in case you have these instances, which you of course have them, right? So you can start practicing them. Okay, and I'll give you the answers for this, so don't worry, the answers will be put up later on over at the end. so that you can just cross check if you're trapped at some steps. Okay, so that this was for this assignment for span. Similar way for RSPAN, you have this configuration. So might be if you want, you can make use of different VLANs apart from 40 and 100. So let's say you if you want, let's say you go with 40 and 100 for simplicity. So let's say this is on 40. On trunking, allow 40 and 100. If you don't add, then basically all VLANs are allowed, both are good. And on this side, wherever you're capturing, make sure it's a different VLAN than what you're capturing. Okay, so capturing VLAN and the RSPAN VLAN must be different. So for RSPAN VLAN, you can take VLAN 100 and you are starting capturing 40, and that's how you can practice it. Okay, before I close this, there is something with respective to ERSPAN. Okay, concept is very simple. It's used for routing mode. Okay, and ERSPAN is a technology which is latest developed. So basically your iOS box and your IOU and IOL, you cannot configure ERSPAN. ERSPAN you can configure on like Catalyst 6500, 7600, or on a Nexus box or an iOS XE. The best that you can try to recreate and test this would be your CSR 1000 whatever it is, KV, or these router, because these router comes with iOS XE family, so you can try this. Okay, so span and RSPAN, basically what they help is they try to help you in copying traffic from one interface to another, right? Both of them does the same thing, copy the traffic from the source interface and put it on the destination analyzer. But what ERSPAN does is, it's for L3 traffic, the traffic that cannot be routed. Okay, the traffic that cannot be routed, you cannot use this. Okay, so whenever you have span and RSPAN, so that's more like you in the case of L2 traffic, when you have something routing involving, then these are the shortage, they are the limitation, you cannot make use of this. In that case, you have to go with ERSPAN, which is encapsulated remote switch port analyzer, with the help of GRE encapsulation. It's not GRE tunnel, it's a encapsulation. The encapsulation that we use is GRE. If you remember, IPsec is one encapsulation, GRE is another encapsulation. These two tunnel encapsulation we also see in the case of SD-WAN data planes. Okay, but by default we use IPsec, not GRE, because of the header payloads, because the header size of GRE is very huge, like close to like 30 to 40 bytes of header this GRE takes, whereas IPsec is very small, like 8 to 16 something. So that's why in the SD-WAN for encapsulation, even though we have two encapsulation, IPsec and GRE, we go with IPsec because of the shorter data size, or the header size, the shorter header size. Okay, so that was short intro about GRE and IPsec. They are encapsulation. The biggest drawback of GRE getting removed from the latest portion is because of their header size. They take a lot of header, and basically what happens, your data gets strinked up. Okay, now this is a limitation of GRE. So in the case of ERSPAN, we make use of GRE encapsulation, and we do the same thing. We capture the source traffic, we send to the destination, and we analyze all those things. So it's better used in the case of routing mode. Okay, so how it works is, ERSPAN, they works on some unique session ID. Okay, like in the case of span and ERSPAN, RSPAN, we made use of some monitor session like 1, 2, right? Similar way, in the case of ERSPAN, while I configure ERSPAN, I have to define a unique session, something like unique session 1. So that's how ERSPAN works. So there's some concept of unique session 1 or unique session ID. Okay, I'm gonna define my list of source interface or source VLAN the similar way we did in the normal span and ERSPAN. I'm going to define the traffic, that is nothing but the filtering. Okay, destination IP address for the GRE tunnel, origin IP address which is used as source because it's source and destination, right? So you're gonna define the from the GRE point of configuration what is the source IP and destination IP, and unique ERSPAN flow ID. Okay, and similar way in the case of destination, the same thing happens when you're defining your destination interface. You have to define your unique session, you will define your destination interface, you define your source IP, and that's how you test. Okay, so if I get a CR 1000 next time, I'll show you the ERSPAN. Okay, I'll show you the lab of ERSPAN, but I just wanted to give you the overview of this particular thing because this is also a part of this topic: span, RSPAN, and finally ERSPAN. Okay, this is used in the used in case of the iOS boxes. Okay, whereas this is used in the case of XC or Nexus or ASR. Okay, on a higher end devices. Fine, so that ends this class. So let me know if you guys have any doubt. I'll give you this document so that you can practice. I have already given you some assignment from the previous topic, which was NAT. Okay, I think small 3 labs from the NAT topic, which you can do it in the weekend. And there's this lab which you can do once again in the weekend. They're very simple things. Okay, so just keeping you guys engaged so that you don't get bored with the class. Keep doing labs so that it helps you. Okay, so you are free to redesign this the way you need. This is just a logical diagram. If you want to recreate the way you have in your organization, you're free to do it. It's all about commands, which it's just a 2 to 3 lines of command, and you know what happens. The validation part is important, so you will expect something happening on your Wireshark, something like this, right? So that's all. Let me know if you guys have any doubt, and we'll take it forward from there then. So for the handling RSPAN, it's iOS family. The SPAN and RSPAN works on little older devices like SPAN boxes like 3750 or 1800. But yes, IOU and IOL, it doesn't work. The command don't work on these boxes. If you see here on my topology, I also have some switches which were kept here, right? So here I cannot use this span configuration, neither span neither RSPAN. So these boxes are still much older than those span and RSPAN to accumulate. So you need to have these VIOS boxes which can handle the RSPAN and VSPAN. These are the standard iOS boxes. Okay, but ERSPAN you cannot configure here, and you need a XC family or Nexus family or a ASR family. So if you have them, you can do it, but the simplest option that I can get it is CSR, because it's a XC family and it's a not very high RAM consuming instances, might be 2 GB, whereas Nexus and ASR will take like 8 GB, and then you guys will suffer getting that up. Might be if you're running on 8 GB of VM, so there would be a lot of issues coming in. So are we all good? Are we all good with this? So you have a lot of assignments. Keep doing. Don't depend on only theory, because theory gradually you will start forgetting. If you start, let's say you started up with a new technology, let's say you started up with SD-WAN or a cloud or a automation, the topics from CCNP you start gradually forgetting. So best thing is keep practicing. Do a simple lab. If building a whole massive takes a lot of time, just you can practice with small instances, like 4 5 instances, and just play around so that you keep them memorized always. So that's my point here. Okay, fine guys. So if there's no issue, there's no concern, we'll take it up in the next class, and see you soon everyone. Okay, have a nice day, and good night from India.